Have you ever tried to find where two lines cross on a graph and you just end up with a big, sketchy mess? Yeah, me too. Well, there's a much cleaner way. Today, we're unlocking an algebraic superpower called the substitution method. And trust me, it's going to change how you solve these problems for good.
So why even bother with a new method? Well, just look at this comparison. Graphing can be a total nightmare, right? It gets messy, it's hard to be precise, especially if you're dealing with fractions. But substitution, that's pure algebra. It is clean, it's exact, and you know what? It works every single time. This is the difference between kinda guessing where the lines cross and knowing for sure.
All right, so what is the big idea here? It's actually a concept you already get without even thinking about it. At its heart, it is all about a simple swap. Kind of like when a coach sends in a substitute player in a big game.
I mean, think about it. A coach subs one player out for another. They're just swapping one thing for another of equal value to the team. Well, algebra does the exact same thing. If the rules tell us that y is equal to 5, then for all intents and purposes, they are interchangeable. So we can literally just pull the y out of our equation and pop the 5 right into its spot. That's the entire game.
Okay, simple enough. But what happens when y isn't equal to a nice, simple number? To make this super easy to see, I'm going to show you a little trick I like to call the blob method. This is the absolute key to handling those more complicated problems without getting all twisted up. So here's the core idea. A variable doesn't have to just equal one number. Nope, it can be equal to an entire expression. With the blob method, we're just going to imagine that whole thing, like this 2x plus 1 here, as one single object, one blob that is perfectly exactly equal to y.
So let's see this thing in action. Our first equation tells us that y is the blob, 2x plus 1. So when we look at our second equation and we see that lonely y sitting there, we know exactly what to do. We literally pick up the entire blob and we drop it right into the y spot. And see that? The parentheses are so important here. They're like a little container, keeping our blob together so it doesn't spill everywhere.
And bam, just like that, look what happened. The y variable is gone. It has totally vanished. This is the magic of substitution. We took a complicated equation that had two different variables and we turned it into a much simpler one with only x's. And this is an equation we totally know how to solve. All right, now that you've got the main idea, let's walk through a full example, from the very beginning to the very end. This is where we put all those pieces together to get our final answer.
Okay, step 1. The rules of the game tell us y is the exact same thing as our blob, negative 2x plus 1. So we find the y in that second equation and we make the swap. See how we get 3x plus 2 times our blob, all equal to negative 2. And yep, there they are again, those parentheses doing the super important job of holding our blob together.
Now we just do the algebra we know and love. First up, we've got to distribute that 2 into the parentheses. That gives us 3x minus 4x plus 2. Next, we combine our like terms. The 3x and the negative 4x hang out and become negative 1x. And finally, we get x all by itself by subtracting 2 from both sides, which leaves us with negative 1x equals negative 4.
And would you look at that? We just divide both sides by negative 1, and we get our first piece of the puzzle, x equals 4. Awesome first step, but hold on a second.
Are we done here? You know, this is a super common spot for people to get tripped up. We found x, which is great, but a solution to a system of equations needs a value for every variable. We're still missing our y.
This is where we use what I call the boomerang step. You take the answer you just found, x equals 4, and you just throw it right back into one of the original equations. Pro tip, pick the simpler one. We're going to plug that 4 back in for x, do a little bit of quick math, and that gets us our second answer, y equals negative 7. And there we have it, the full, complete solution. It's not just a number, right? It's a coordinate pair. This is the single exact point, 4, negative 7, where those two lines would cross on a graph. No guessing, no messy drawings, just one perfect, clean answer. Okay, so you get the process. Now let's switch into mastery mode. I want to show you the two biggest traps that students fall into, so you can just sidestep them like a pro. All right, listen up, because this is important. If there is one single mistake people make with this method, this is it. Forgetting to wrap your blob in parentheses. It seems like such a tiny detail, but I promise you, it will completely change your entire answer.
I mean, this slide shows the damage perfectly. On the left, without parentheses, it's so easy to just multiply the 2 by the negative 2x and totally forget about that plus 1 at the end. But on the right, the parentheses force you to distribute correctly to both things inside. One tiny mistake, one completely different and wrong answer. And the second huge trap? Getting so excited that you found x that you just stop. Don't stop halfway. Finding that first variable is only half the battle. A full solution needs the full coordinate pair. So please, whatever you do, always remember the boomerang step.
So let's be real. Why does any of this matter outside of your next math test? Well, it turns out you're actually learning the fundamental logic that powers the technology you use every single day.
Take a look at this little piece of code. A programmer tells the computer, hey, the variable tax rate is equal to 0.05. Then, later on, when the computer gets to this formula to calculate the total, what do you think it does? It sees tax rate, and it substitutes in the value it knows, 0.05. It's doing the exact same thing we just did with our blob. This is literally how software thinks.
So the big takeaway here is this. Every time you solve a substitution problem, you're not just learning math. You're literally training your brain to use the same exact logic that builds the software, the games, and the apps on your phone. It's the engine that runs the digital world. So next time you're scrolling, think about it. What other systems are secretly running on a simple little substitution?